first USP. We create a graph of the entire system. For example, login is itself is a node, accessing database is a node, and the edge between those nodes basically defines the node. The user can go from this state to this state. If there is no edge, the user cannot go across that state and reach to another node. Now, in this way, we create the entire system's graph. We don't take any personal information or any credit card number or etc. We just need the system state in that, so that whenever user does a lateral movement in the graph, we can detect it. Now, for generative parsing, what we do is that we create lots of different types of graph from the different from the original graph. We pass it through different protection layers, and whenever there is a filtered graph, basically that means it can pass through the protection layer. That means the path in the graph is dangerous. So we match it using our original graph. In that way, we can detect in which paths are different from the original, and basically that path is a vulnerable path. And indeed, in that way, before even the attacker attacks our system, we are able to know what is the vulnerability in our system, and we can basically prevent the vulnerability by fixing that thing.
Okay, so our second USP is AI-driven access control system. Our system fundamentally replaces static network security and replaces it with the AI-driven approach. For example, in current systems, once a user enters a network or a subnet, they gain broad access. This creates a major vulnerability because if an attacker breaches one point, then they can move laterally across the system. Our approach eliminates the risk by implementing a zero trust inspired model like that implemented by Cisco. But our changes, we are using generative AI by it because the network is not going to be based on the location only, but we are going to track the identity, behavior, and real-time context. Every user or device is continuously authenticated using cryptographically generated time-bound tokens. These tokens are then dynamically created and strengthened using techniques similar to salting and secure hashing, making them extremely difficult to reuse or forge. What makes our system unique is the integration of generative AI. This AI is going to continuously analyze the user behavior, create intelligence and risk scores, and based on this, it dynamically updates the user access permissions, rotates the credentials, and adjusts the security policies in real time. Higher-level security systems become stronger because suspicious users are automatically restricted in them, which creates a moving target defense, thereby and not enabling the attacker to lock in at a fixed position. Similarly, we are going to talk about our last USP, which is an AI-powered deception system based on the honey traps of the real life. For example, in Connect system, the honey trap or limited fake hotspots are being created where attackers are being lured into, and this is going to be implemented by our generative AI model because instead of simply blocking suspicious activity, our system redirects attackers in dynamically fake generated environments. These seem extremely realistic because they are linked with fake databases, admin panels, and also believable system responses. The attacker is led to believe that it has leads to a high-value system, but they are isolated in a controlled environment. Also, they are going to be misled in that environment by creating fake attack paths and looping them through control nodes, keeping them engaged, and at the same time, their information itself is going to be monitored. So it becomes a sort of a reverse attack system. By generative AI, we are going to lock them in a fake environment and also going to track their behavior so as to track them and also train the model for future attacks and make it adaptive. In essence, the attacker's success is an illusion and a trap for our own game. Thank you.